Hi everyone, in today's video we are going to be looking at number patterns. We will be covering on number sequences where you will be learning what number sequences are, how to recognize patterns in number sequences, and finally how to find a formula for the general term of a number sequence. Let's first understand what number sequences are. Consider the following whole numbers. We have the numbers 2, 5, 8, 11, and 14. This is what we call a number sequence. In a number sequence, there is usually a pattern going on. And in this particular number sequence itself, there is a pattern of addition of 3 from one term to the other. So from 2 to 5, we know that we add 3 to 2 and we will get 5. And from 5 to 8, when we add 3 to 5, we will get 8. And so on. Okay, we will be able to get 11, 14, and so on. So in this number sequence that we have, it is being governed by a specific rule that I just mentioned and just described. There's a way for us to describe this rule. We say that it starts with 2. So mentioning the starting number is very important because if it doesn't start with a number, then how will we know how to continue, isn't it? Then we add 3 to each term to get the next term. So when we refer to the word term itself, it refers to the number, okay, in the sequence. So this is what we call the first term, second term, third term, fourth term, and fifth term. And this is what we have. Let's start by taking a look at this question here, where we're trying to find the rule that generates the sequence. So in this very first sequence, we have 42, 39, 36, 33, and 30. And then, of course, so on and so forth. So in this number sequence over here, what do you think is the pattern going on? I hope that you're able to recognize that the pattern going on is that there's a subtraction of 3 from one term to the other. So from 42 to 39, it is a subtraction of 3. And then from 39 to 36, there's also a subtraction of 3. So what this means is that for the rule itself, we will always start off by saying what it actually starts with, or rather what is the number that it starts with. In this case, that will be 42. Then we follow by stating out what the rule is, which I mentioned earlier. That would be subtraction of 3 from each term to get the next term. Okay, then in finding out what are the next two terms, starting from 30, we continue to subtract 3 and therefore we get 27. Then we minus 3 again and we get 24 as our next term. In another example, we have the sequence negative 22, negative 18, negative 14, negative 10, and negative 6. Looking at this number sequence, what do you think is the pattern going on? Be very careful because in this case, we have negative numbers. So I hope you're able to see that from negative 22 to negative 18, we are actually adding 4, okay, from one term to the other. So the rule in this particular case is that we start with negative 22 and then we add 4 to get the next term. So with this rule that we have in place for this particular number sequence, to determine the next two terms, we will take negative 6 and plus 4. That will give us negative 2. And then taking negative 2, we add another 4 again. We will get the next term to be 2 itself. Let's look at another one here. In this particular sequence, we have the numbers 256, 128, 64, 32, and 16. Do look at the numbers carefully. What do you think is the pattern going on in this particular sequence? I hope that you're able to observe that it is actually a division of 2 from the first term to the next term and then subsequent terms as well. Okay, so with this particular rule that we observe, we write it out as starting with the number 256, then divide each term by 2 to get the next term. That will be our rule for this number sequence. And the next two terms would actually be 8 as well as 4, because 16 divided by 2 gives us 8 and 8 divided by 2 gives us 4. Let's look at a final one for this concept, where we have the number sequence -1, 1, -1, 1, and -1 again. So it alternates between a negative 1 itself and then a positive 1. So what do you think this pattern is? Do keep in mind that in all our rules that we covered, we are either subtracting, adding, or else multiplying a number. Of course, we can also divide as well. Okay, so therefore, in this case, what do you think is the operation going on? Okay, if we have determined the operation, is it consistent throughout the entire number sequence? Whether is it actually the same addition, subtraction, division, and multiplication of a same number, or is it a different number all the time? In most number sequences, the number is usually the same. So I hope you're able to see that we are actually multiplying by -1. Okay. However, if you're thinking, or if you were thinking that it is a division of -1, it does work as well, because we do know that -1 divided by -1 does give us a 1. In this particular case, choosing either a multiplication or a division doesn't quite matter. So I've already chosen to do multiplication. In this particular case, my rule will then be stated as starting with -1, then multiply each term by -1 to get the next term. And my next two terms are quite obvious. It will actually be +1 followed by -1. I hope that with these 4 questions, you are able to understand how we write and generate a rule for a number sequence. Moving on, let us learn about what a general term actually refers to. So let us consider this very familiar number sequence. We have the numbers 2, 4, 6, 8, and 10. So earlier on, when I introduced to you a number sequence, I told you that in this particular case, our number 2 will be called the first term, number 4 refers to the second term, 6 refers to the third term, and so on. So instead of labeling them as first term, second term, third term, and so on, which sometimes can be rather tiring to write, we can actually use a certain notation and label them as capital letter T with a small one at the bottom right corner. Okay, so we write it as T1, T2, T3 to correspond to the meaning of first term, second term, third term. Okay, so from here onwards, I will be using this notation of capital letter T followed by a small number to represent the different terms in a number sequence. So for this particular number sequence, we can say that first term T1 is equal to 2, T2 equals to 4, and up to T5 will be equals to 10. So what exactly is a general term then? The general term is actually a formula that helps us to determine a particular term without having to go through tedious calculation. For example, let's say I want you to find out what is the number found in the 1000th term, or in this case 100th term. While it may be easy for us to know in this particular number sequence, we know that it will probably be 200. My question to you is, how do you know that it is 200? Okay, so you probably have a formula in your head. That formula that you have in your head is what we call the general term formula. Okay, so knowing this formula helps us to simplify the need to write a rule, because earlier on you saw how we have to write the rule, whereby we start off with the number followed by a written description of how it actually progresses from one term to another. Therefore, knowing a formula for a general term will help us to simplify those writing. So for this particular case, we will actually describe it as start with 2, then add 2 to each term to get the next term. So whenever we want to find the general term in a particular number sequence, okay, usually we will construct a table. Your table need not be a fully drawn table, but of course, if you could draw one very neatly, that will be wonderful, but it shouldn't be too messy such that I am unable to understand what you're writing. Later on, I will present to you some examples for you to see how is it that you could actually write your answers. So usually we're looking at a table that looks like this, okay? Following, in this case, our position or our term number is 1, whereby the term itself is the number 2. And then the position number 2, we have the value of 4. Position number 3, I have the value of 6, and so on for position number 4 and position number 5. Okay, instead of writing the word position, sometimes we can use the letter N to represent it as well. Okay, I do have a letter N over here. This N is meant to be the general term. Okay, so the general term means that, for example, if after I progress from 5, okay, 6, 7, 8, right in somewhere, okay, in this particular sequence, I just use the letter N to represent it, okay, and I want to determine the formula itself. Okay, so in most of the time, my formula will be in terms of N. Alright, so let's move on to learn how is it that we can generate a formula for this particular number sequence. So let me create my table slightly larger. I have already changed my header over here. Instead of calling it position, I change it into N. Alright, so I want to figure out the formula, okay, for this very last row. Okay, so our very first term is actually 2. We know that we go from 2 to 4 by adding another 2. Okay, so therefore it is actually a 2 plus 2 that gives me 4. From 4 itself, I add another 2. That means that if I count from the start, I'm adding 2 and 2 again. Therefore, I write 2 plus 2 plus 2. It is as good as saying our original 4, which is 2 plus 2, I add on another 2. Similarly, when I go on to the fourth term, I will add another 2 from the 6 itself. That will mean that it is 2 plus 2 plus 2 plus 2. Following that, in my fifth term, needless to say, I hope you see that, that will actually be an addition of 5 2's. As mentioned, because I said that in my fifth position or my fifth term, there are actually 5 2's. I could always simplify my writing of this number of 2's here, okay, into 2 plus 2 as 2 times 2, 2 plus 2 plus 2 as 2 times 3, 2 plus 2 plus 2 plus 2 as 2 times 4, and finally for our fifth term, it will be 2 times 5. Okay, so this that I wrote written in red, right, is actually the simpler way of writing instead of writing it in such large extent. Okay, because it can go on forever if my number sequence continues to go on. Alright, so I will use this simplified version of writing, okay, to generate or to create my general term formula. Right, but before that, I want us to also be aware that 2 itself, our very first term, is actually 2 times 1. So what do you notice about all this that I've written in red? I want to bring your attention that my 2's, okay, over here that I've highlighted in green, remains the same throughout every single term. So be it whether is it the third term, the fourth term, or even the first term, there is always this 2. This will tell me that for a general term, okay, in a generic manner, my formula itself must have these 2. Okay, this is by observation from all the previous terms itself. Next, I want us to observe the numbers in the brackets. I have 1, 2, 3, 4, 5. Do you notice that this sequencing, okay, is actually the same as my term number n? So I want you to see that as I highlight, it actually compares to be the same as my n over here. That will mean that, okay, for any term itself, okay, if it's an n term number n, that will mean that this is equals to 2 times n. Okay, so with 2 times n, obviously I need not to have the brackets at all. I could always simplify it to 2n. And therefore, for this particular number sequence of 2, 4, 6, 8, 10, I will have the general formula that I will write as T, capital letter T, and then a small n equals to 2n or 2 times n. But instead of writing 2 times n, I urge you to write 2n instead. So let's move on to another question to further our understanding about the development of the general term itself. So let's look at this question here. Okay, we want to find a formula for the general term of this sequence 7, 11, 15, 19, 23. Okay, so this is a question where I want to show you how you could present your answer in a neat manner if you choose not to actually draw a table. Okay, please do make sure that you have the headers n and tn, okay, to represent n as the term number and tn as the particular term itself. Do arrange it in a neat manner and ensure that they are actually aligned. Please don't draw it or write it such that it is slanted, okay, and then it becomes very difficult to read. The worst is that people misunderstand what you're trying to calculate, or you actually misread yourself and then end up you have careless mistakes in the end. Okay, so in this particular number sequence, I want us to observe what the number pattern is going on over here. So from 7 to 11, what you should observe is that it is an addition of 4. Likewise, from 11 to 15, we add 4 as well, and so on for the rest of the terms. So what this means is that for my second term, okay, 11 over here, I'm taking 7 at the start, adding a 4, so 11 equals to 7 plus 4. Then for my 15, I will add 4 to 11, which is 7 plus 4 plus 4. Followed by 19 is arrived by getting 7 plus 4 plus 4 plus 4. And finally, our fifth term is actually 7 plus 4 plus 4 plus 4 plus 4. How could we reduce writing so many 4s? Okay, we can simplify it by writing as 7 plus 4 times 1, then for the second term, and then 7 plus 4 times 2, followed by 7 plus 4 times 3, and finally 7 plus 4 times 4. This is definitely neater to write as compared to this long series of numbers that I wrote in blue. So going backwards, do not forget your first term. How do I write it in the same manner of 7 plus 4 times a certain number? Okay, for our very first term, I did not add any 4 to it, so it is simply 7 plus 4 times 0, since there are no 4s. Okay, so similar to the earlier example, we look at this red writing that I have over here. What are the numbers that are actually the same throughout every single term? I hope you recognize that it is 7 that is always the same. So therefore, in my general term, I must have a 7. There is also another thing that remains constant, remains the same throughout, and that will be our plus 4. As a result, I will write my plus 4 in as well. What changes throughout, okay, my sequence is the numbers that are found in the brackets. Now I want us to observe this. Okay, so for the number 0 over here, how does it relate to the term number? So our term number is 1 over here, and then we have the number in the bracket to be 0. In our second term, we have a term number 2, and the number in the bracket is 1. for the term number 3, the number in the bracket is actually 2. Not sure whether you see any pattern going on, but in fact, it is always a minus of 1 from the term number. So from 4 itself over here, when I minus 1, I will get 3. And 5 minus 1, I will get 4. So by observing the term numbers and the numbers in the brackets, we observe that if my number over here is n, okay, using just a variable to represent it, what do you think will be the number inside the bracket? It would be n minus 1. But we should not leave our answer as such. Let's expand and simplify it. So this is actually a 4 times n minus 1. So 4 times n will give us 4n, and 4 times minus 1 will give us a negative 4. Upon simplification, I will have 7 minus 4, that is 3, and then 4n continues. Therefore, from this set of working, I can conclude that my term number is not, my general term, not term number, my general term Tn is equals to 3 plus 4n. Alright, I hope that you're able to understand my explanation over here. Do take some time, okay, to actually think through how is it that I solve this question. Now that we have learned how we generate a general term formula, we will next look at how is it that we can use the general term formula to help us determine the number found in a particular sequence. So in this question, they did not give you a sequence of numbers. It says that given that the nth term, Tn, of a sequence follows this formula, 5n minus 3, we want to know what the third term is. So we use this formula, 5n minus 3, to help us determine the third term. And that could be done by changing my n to 3. So when I replace the n into 3 for 5n minus 3, please make sure that we have brackets because 5n means 5 times n. Hence, we must have 5 times 3. So 5 times 3 minus 3 will give us 12. Therefore, the third term is actually 12. In part 2, we want to find the difference between the third term and the fifth term. And therefore, my fifth term will be 5 times 5 minus 3, where I replace the n by 5, and that will be equals to 22. And then my difference will actually be the subtraction of the larger term, 22, minus away the smaller term, 12. Hence, the difference is actually 10. We have come to the end of our number sequences lesson. So I hope that you have already covered and learned what number sequences are, how to recognize patterns in number sequences, and most importantly, how is it that we can find a formula and use that formula for the general term of a number sequence.